Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about arc length in Calc 2 or Calc 1, depending on your college or high school. So first, when we're talking about arc length, I think this is assumed already that you know this, but basically we're going to be able to find the exact distance, like if you had a ruler that could measure from here to here, we can actually measure this exact distance using integrals. And here's how. Here's the formula. L arc length is equal to the integral from x1 to x2 of the square root of 1 plus, put this in parentheses, f prime of x, the derivative, that whole thing is squared, and then we'll cap it off with a dx. And so whenever you're given a problem about arc length, you're always going to be given two things. Number one, you're going to be given the function f of x. And number two, you're going to be given some values to measure between x1 and x2. This could also look something like this. And because variable notation is confusing, and I know that, here's an example with actual numbers. Let's say the function is the square root of 2x minus 4. And we want to find the arc length on the interval from 2 to 8. In other words, 2 less than or equal to x less than or equal to 8. And for this one, I'm just going to ask you to set up the integral. I'm not going to ask you to solve it. They do this a lot of times in this class because sometimes the integral is just too hard to solve or it takes too long. So a lot of times we just want to set up the integral, not solve it. So if I want to solve this, I just need to take the derivative of square root of 2x minus 4. Hopefully you know this from Calc 1. The first thing you should do is rewrite this to the 1/2 power. This is still the original function. We did not take the derivative yet. Now the derivative here will be a chain rule, and what that means is the 1/2 exponent is going out in front. The 2x minus 4 stays the same, but now it's 1/2 minus 1 power, so negative 1/2. And then the thing most kids forget is you need to multiply by the chain rule, in other words, the derivative of the middle, which in this case, derivative of 2x minus 4 is just 2. The 2 and the 1/2 cancel, and so the derivative is going to be 2x minus 4 to the negative 1/2 power, which I'll always rewrite my negative 1/2 power as a square root in the denominator. So as you can see, there's my derivative. And since I have the values, it was between 2 and 8. It's going to be easy to write this integral. It's going to be the integral of 2 on the bottom, 8 up top, square root of 1 plus this thing squared, and then dx. And if you want, this last step is optional, just a little bit of simplifying. Square root and squared basically cancel each other out. So really what we're looking at is this integral, which, as I said before, is not going to be solvable, at least not for us today. So that's it. That's going to be our answer for this one. Okay, so now we're just going to do one more example to wrap it up for today. This time the function is f of x equals 9 plus x to the 3/2 power. This is going to be on the interval of 0 less than or equal to x less than or equal to 7. And you can set up this integral, but I am going to ask you to actually solve it. I want you to solve the integral to find the exact arc length. This one is going to be possible, I promise. And if it's not, then I'm just going to cut the video short and apologize later. So why don't you give this one a try on your own now? Pause the video, give it a try, and see how far you can get without me. Okay, so time's up. The first thing I would do if I were you is find the derivative. Derivative again will be chain rule. The 3/2 comes out in front. 9 plus x goes in parentheses. This is now raised to the 1/2 power because 3/2 minus 1 is 1/2. And then multiply by the derivative of 9 plus x, which is just 0 plus 1. So in other words, just 1. So there's my derivative. Now setting up the integral, L is going to be equal to, bottom bound was 0, top bound was 7. It's going to be the square root of 1 plus 3/2, 9 plus x to the 1/2, and then all of that's going to be squared dx. And actually, now that I look at this, maybe this isn't possible, but let's see. I'm not giving up hope yet. integral from 0 to 7 of 1 plus. For this squared, you have to square everything. In other words, you have to square the 3 halves, which is going to become 9 fourths. And because only the 9 plus x was raised to the 1 half, this 1 half and this squared will cancel only for the 9 plus x. In other words, 9 fourths, keep that there, and then 9 plus x, there it is. No more powers, they cancel each other out, and then dx. I'm now going to distribute that 9 fourths to both terms, because that's perfectly legal and a good idea. So it's going to be 1 plus 81 fourths plus 9 fourths x dx. And now that I see it, yes, this integral can be solved. Thank goodness. So first, let's add 1 plus 81 fourths, because remember, 1 is really just 4 fourths. So 4 plus 81 is 85. So we really have 85 fourths plus our 9 fourths x. Okay. And now in case you forget how to solve this, this is just an easy u substitution. U is going to equal the thing inside the square root, 85 fourths plus 9 fourths x. Du dx, the derivative, is just going to be 9 fourths. At this point, I want to solve for dx, so I cross multiply, and then I'm going to divide both sides by 9, and there's my dx, 4/9 du. So now my integral is looking like integral from 0 to 7. Technically those bounds change when I do the u substitution, but I'm going to change them back at the end, so ignore what I just said. Integral of u, because everything under the square root just got replaced with u, and then the dx just got replaced with 4/9 du. Yes, that 4/9 can go out in front of the integral. And the square root of u I am going to rewrite as u to the 1 half du. And then this is just an easy power rule. So that means I have to add 1 to the exponent, u to the 3 halves, and then divide by 3 halves. But since I never divide by fractions, I'd much rather multiply by the reciprocal. It's going to look like that. And then u to the 3 halves. 4/9 times 2/3, that's going to be 8/27. None of that reduces. So 8/27, plug back in for the u, which was 85 fourths plus 9 fourths x. Remember our original bounds, 7 to 0. And then you just plug in the 7, which I don't really feel like doing that much. But 7 times 9 is 63 fourths. And then minus when we plug in 0, which will just leave us with the 85 fourths. So whatever this comes out to, I guess I'll get a calculator real quick. You would get 4.6 repeating, or as a fraction, it's going to be 14/3. And that's the answer for that one. Or if you just wanted to stop at the integral, you could have stopped right here. And that's how we set up the integral. So that's going to do it for this video on arc length. Thank you all for watching. Hope you have a great rest of your day. And I'll see you in the next video. Take care and bye-bye.